Hey everyone, welcome back to the channel. Today we are diving into one of the most powerful and scalable database in AWS called Amazon DynamoDB. If you ever worried about managing servers, handling millions of requests, scaling database or managing uptime, DynamoDB solves all of that. It's a fully managed serverless auto-scaling NoSQL database. Remember, it's a NoSQL database trusted by companies like Netflix, Airbnb, Amazon, and TikTok. In this session, we'll break down DynamoDB into super simple pieces: tables, items, attributes, keys, index, streams, capacity modes, global tables, all explained with clean diagram and real-world examples. So let's begin. First, we'll understand what is DynamoDB. So it's a fully managed NoSQL database by AWS. Remember this point? Fully managed NoSQL database. And it's serverless, means no servers to manage. And this point is important, it's NoSQL database and it's serverless. Second, it's auto scale to millions of requests per second. Third point, it's predictable single digit millisecond performance. And it's high available across multiple ability zones. Supports both key value and document data. Remember, it supports both key value and document data. You focus on your application, AWS handles everything else. Next, why DynamoDB? Question comes. So problem with traditional database, hard to scale, manual shading, complex replication and failover. Performance drops during spikes. So DynamoDB fixes with auto shading, auto replication, serverless infra, unlimited scalability, and consistent performance. Next, we'll see core components of DynamoDB building blocks. So we have tables, items, attributes, flexible schema, and JSON-like structure. So what is table? It's like a container of data. And after that, items, a single row slash record in JSON object. And attributes is properties or columns. For example, suppose we have people table and each JSON object is equal to one person. Next, we'll see what is primary key. So there are two types in DynamoDB. Well, first one, simple primary key. Second, composite primary key. So simple primary keys, only one attribute determine physical storage partition must be unique per item. So again I am repeating, simple primary key has partition key, only one attributes and determine physical storage partition must be unique per item. Then comes composite primary key. So it's partition key plus sort key. Many items can be shared partition key. Sort key orders item within partition. So partition key, PK customer ID, sort key, order date, sorted query like latest order date range. Now next we'll see secondary index. So we have global secondary index, GSI local secondary index, and query by non-primary attributes. DynamoDB Streams. So it supports capture, insert, updates, and delete. So it's what is DynamoDB Stream? So real-time event tracking. So stream capture, insert, update, delete. Each event includes like before image, after image, timestamps, and use streams plus Lambda for sending emails, loggings, syncing data, trigger based workflow. So events retained for 24 hours. Its retention period is 24 hours. Next, table classes. So DynamoDB offers two classes, standard classes and standard infrequent classes. So standard is default and standard IA infrequent access. So default is normal workload for it is useful for normal workload, and standard infrequent access is useful for cheaper for logs, archives, index inherited tables class automatically. Now we'll see capacity modes. So the first one is provision capacity, second one is on demand capacity. So where we can use provision capacity. So it's useful for predictable traffic, set RCUs and /WCU, and for auto scaling it's optional. Then we have on demand capacity. This one is provision capacity. Then on demand based for unpredictable workload, and you can pay per request. Next slide we'll see serverless benefits. So as we know, DynamoDB is fully serverless. So we have no server to maintain, no patching, no scaling configuration. Automatically handles millions of requests per second. Highly available and multi-ability zone. And it's for predictable performance. Next, global tables. So active multi-region application. What is the use of global tables? So it's used for ultra low latency for global apps, multi-regions read write, disaster resilient architecture, perfect for worldwide users, used by gaming, e-commerce, banking, IoT apps. So global tables we can use for gaming, e-commerce, and banking and IoT apps. Next, we have integrations. So Lambda, we can integrate with Lambda, Kinesis, S3, Glue, and with CloudWatch, CloudTrails Analytics. Now we'll see best use cases. First, for user profiles, session data, gaming leaderboards, shopping carts, IoT device, real-time data analytics, chat applications, high-speed mobile apps. So these are the best use cases. Remember, for user profiles, session data, gaming leaderboards, shopping carts, IoT device. Now we'll see the final summary, what we achieved and what we have learned so far. So DynamoDB gives is fully serverless, fully managed NoSQL DB. It has tables, items, attributes model, simple and composite primary key, streams for event-driven apps, on-demand or provision capacity, multi-region global data tables, and ideal for modern internet scale and real-time apps. So that's all I have covered for this DynamoDB. Next we'll see some more database of AWS. We have lots of database left to go through. So thank you for this video. We'll see you in another video.